Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be adding and subtracting rational expressions. Before we get into it, let's look at a couple of steps. So when you're adding and subtracting rational expressions, the first thing you're trying to do is trying to find a common denominator. So sometimes we have to factor the denominators to find that common denominator. In step 2, once you've factored the denominators, then you're going to find the least common denominator, or the LCD. Then you will multiply each fraction, top and bottom, by any factor missing from the LCD. Then add or subtract the numerators. Then you'll simplify the numerator by combining like terms. Be careful to distribute the negative when subtracting. And step 6, you'll check to see if the final result can be simplified further. Sometimes when you're done, the numerator will factor further and allow you to cancel common terms. So let's look at example 1. Now, some of these problems have quite a few steps. So if I start going too fast, just pause the video until you can get everything written down and then start it again. All right. I will not be explaining the factoring too much, and so if you need a review on factoring, you might want to go back and review that before attempting this lesson. All right. In example A, we have 6r minus 2 over 10r minus 20, and we're subtracting the fraction 1 over r minus 2. So we're trying to find a common denominator here so that we can subtract these two fractions. So in step 1, it says to factor the denominators if necessary. So if I'm looking at my first denominator, 10r minus 20, I had noticed that I have a common factor of 10. So if I divide out a 10, 10r divided by 10 leaves me r, and 20 divided by 10 leaves me 2. Once you do that, it's easier to see that your LCD, we're going to need a 10 and we're going to need an r minus 2. All right. So in step 3, we're going to multiply each fraction, top and bottom, by any factor missing from the LCD. Well, our first denominator, we have both components of the LCD. We have the 10, we have the r minus 2. So we're not going to need to multiply it by anything. Now, my second denominator, r minus 2, I'm missing the 10. So I'm going to have to multiply the top and the bottom by 10. Now notice when I multiply by 10 over 10, 10 over 10 is equal to 1. So I'm not changing the value of the expression at all. Now let's rewrite these two fractions here. My first fraction would be 6r minus 2, and keep your denominator in factored form, 10 parenthesis r minus 2, minus, on my second fraction, I'm going to have to multiply this 1 times 10, which that would still be 10. And then when I multiply the 10 and the r minus 2, I get 10 parenthesis r minus 2. Now, let me state again, always leave the denominator in factored form. Never multiply it out. It'll make it more complicated when we get to the final step. All right. Now, hopefully you remember that subtraction is the same thing as addition of the opposite. So I'm going to change this addition, this minus to an addition, and I'm just going to change the positive 10 to negative 10. Now we can combine like terms and write with a common denominator. So we would have 6r. Oops, I wanted to do that in red. Let's see, where's the 6? So we have 6r, and then negative 10 plus negative 2 would give me negative 12 over our common denominator of 10 parenthesis r minus 2. Now, in this next step, you're about to see why I asked you to keep your denominator in factored form. And that's because sometimes in step 6, the final answer can be simplified further. Because if you look at the top, 6r minus 12, it has a common factor of 6. So if I were to pull that 6 out of there, I would get 6r divided by 6 would be r. Negative 12 divided by 6 would give me minus 2. 10 parenthesis r minus 2. Now, hopefully what you notice is now we have a common factor on the top and bottom, the r minus 2, and those will divide out to be 1. Okay, and then 6/10 would reduce further to 3 over 5. So our final answer is 3 over 5. All right, problem B. We want to first start out by factoring both denominators if necessary. So our first denominator here, I can factor out a 5, which will leave me x minus 2. My second denominator is x minus 2. That will not factor. So now for my LCD, I'm going to need a 5, and I'm going to need an x minus 2. All right, pause the video and try this problem from here on your own. All right, welcome back. Hopefully you saw that our first fraction will not need to be multiplied by anything because I have both components of our LCD. I have the 5 and I have the x minus 2. Our second denominator, however, this x minus 2, I'm missing one of the components. I'm missing the 5. So I'm going to need to multiply this by 5 over 5. All right. So our first fraction would remain the same, x squared plus 16 over 5 parenthesis x minus 2. And my second fraction, I would have to multiply this 4 times 5, so my new numerator would become 20. And then 5 parenthesis x minus 2. Remember, please leave all denominators in factored form. All right, now we're ready to combine the numerators. However, this is a subtraction problem, so I want to change it to addition of the opposite. So I change the minus to a plus, and I change the positive 20 to a negative 20. All right, let's combine like terms. On the numerator, that would leave me x squared. 16 minus 20 is minus 4 over 5 parenthesis x minus 2. Now, before you box that in, you want to look at the numerator. You want to ask yourself, will the numerator simplify any further? Well, x squared minus 4 is a difference of 2 squares. So we can factor the numerator further into x plus 2, x minus 2. In the denominator, we have 5 parenthesis x minus 2. Now, look for any common factors that can cancel, and I notice I have an x minus 2 and an x minus 2 here. So our final answer would be x plus 2 over 5. All right, problem C. We have 7 over x plus 8 plus 3 over x squared plus 11x plus 24. Now, the x plus 8 will not factor, but the x squared plus 11x plus 24, I could rewrite that in factored form by using an x and an x for the x squared and a 3 and an 8 for the 24, both positive. So I can notice now that my LCD, for my LCD, I'm going to need an x plus 8, and I'm going to need an x plus 3. So when I look at my first fraction, I have the x plus 8, but I'm missing the x plus 3. So I will multiply x plus 3, x plus 3. Now, my second fraction, I have the x plus 8 and I have the x plus 3. So I already have both components of the LCD. So I don't need to multiply it by anything. It's really like multiplying it by 1 over 1. I don't need to multiply it. Okay, so let's deal with the first fraction. We need to multiply this 7 by the x plus 3. So 7 times x gives us 7x. 7 times 3 gives us 21 over x plus 3, x plus 8. All right, plus, I didn't multiply the second fraction by anything, but I do want to write it, the denominator, in factored form. All right, now that we have a common denominator, we can just add like terms. So we have 7x. 21 plus 3 gives us 24 over x plus 3, x plus 8. Then you look at your numerator, 7x plus 24. Are there any common factors there that can be factored out? And for this problem, the answer is no. So you box in your final answer. All right, pause the video and try problem D on your own. All right, welcome back. Hopefully you took that first fraction and you broke it down to x plus 2, x plus 3, and then you identified your LCD as x plus 2, x plus 3. And then you noticed that you didn't need to multiply the first fraction by anything, but the second fraction was missing the x plus 3. So when I rewrite this, I'm going to have x squared minus 5 over x plus 2, x plus 3. On the second fraction, if I multiply 1 by x plus 3, I'm just going to get x plus 3. And then the denominator, again, it doesn't matter what order you write it down in. Now, combine like terms. So x squared, nothing to combine it with, plus x. Negative 5 plus 3 is negative 2. And then my LCD goes on the bottom, which was x plus 2, x plus 3. And then we need to ask ourselves, will the numerator factor? Well, I think it will. I could use x and x for x squared. For 2, I could use 2 times 1 if I make the 2 positive and the 1 negative. And so x plus 2, x plus 3. And then you look at that to see, do you have any common factors that will simplify? And sure enough, the x plus 2 and x plus 2 will divide out to be 1. So that leaves us x minus 1 over x plus 3. All right, problem E. We have m squared plus 5m plus 6 over m squared minus 4. And the m squared minus 4, I could factor that to m plus 2, m minus 2. Now my second denominator, m minus 2, will not factor. So I need, for my LCD, I'm going to need an m plus 2 and an m minus 2. An m plus 2 and an m minus 2. Which means the first fraction has both components of the LCD, so I don't need it to multiply by anything. But my second fraction, I have an m minus 2 in the denominator, so I'm missing that m plus 2 component. So m plus 2 over m plus 2. Multiply that by that fraction. So my first fraction is going to stay the same. M squared plus 5m plus 6 all over the LCD, which is m plus 2, m minus 2, plus. For your second fraction, we're going to multiply everything by 2. So that would be 2m plus 4 over the LCD, which is m plus 2, m minus 2. All right, now this is addition, so we can just combine like terms. We have m squared, nothing to combine it with. 5m plus 2m gives me 7m. 6 plus 4 gives me positive 10. And then write down your LCD, which is m plus 2, m minus 2. Now, the last thing you want to do is look at your numerator, m squared plus 7m plus 10, and ask yourself, can that be factored? Well, I think it can. If I used m times m for n squared and 2 times 5, make them both positive, that will work. Now, that's all over. Our LCD, m plus 2, m minus 2. All right, then we ask ourselves, will any of the factors cancel? And sure enough, the m plus 2's will cancel. So whatever's left over is your final answer, m plus 5 over m minus 2. All right, problem F. 2 over 4p minus 20 plus p minus 6 over p squared minus 8p plus 15. Now my first denominator, I can factor out a 4, which that'd leave me 4 parenthesis p minus 5. My second denominator, I could break down to p times p. For the 15, I'm going to use 3 times 5, making them both negative. So for my LCD, I'm going to need a 4. I'm going to need a p minus 5. And I'm going to need a p minus 3. Now, look at your first denominator. We have the 4. We have the p minus 3. What we're missing, we have the 4. We have the p minus 5. What we're missing is the p minus 3. So my first fraction would get multiplied by p minus 3 over p minus 3. Now my second fraction, I have the p minus 5, I have the p minus 3. What I'm missing is the 4. So my second fraction is going to get multiplied by 4 over 4. All right, pause the video and try the rest of the problem on your own. All right, welcome back. Hopefully you multiplied this top numerator 2 by p minus 3 to get 2p minus 6 over 4 p minus 3 p minus 5. Again, doesn't matter what order you write your denominator down in. And on your second fraction, hopefully you multiplied everything in there by 4, so that would give you 4p minus 24. And on the bottom, you would have 4p minus 3 p minus 5. All right. Now, hopefully the next thing you did was combine like terms. So 2p plus 4p is 6p. Negative 6 minus 24 was negative 30. And then 4p minus 3, p minus 5. Now, if you got it to right there, great job. This is not an easy concept to get. So if you got that far, you're doing really good. However, there is one more step in this problem, because if you look at the numerator, there's a common factor of 6 that we can divide out. So 6 parenthesis p minus 5 over 4 parenthesis p minus 3 p minus 5. Now once we have that, that allows us to divide the p minus 5's will divide by 1. And the 6 and the 4 will both divide by 2. So that would leave me 3 over 2. Now for my final answer, all that's left on top is a 3. And what's left on the bottom is a 2 parenthesis p minus 3. So great job if you got all the way to the end without making a mistake. These take a lot of practice and a lot of getting used to. All right, problem G. Now we're back to subtraction. So we have to be extra careful on subtraction. But subtraction problems start just the same as all other problems. We're going to break down our denominators. So I think I could use x plus 2, x plus 3 on this one, and on this one, x plus 2, x plus 2. All right, so for your LCD, I'm going to need an x plus 2, an x plus 3, and another x plus 2. All right, so if I look at my first denominator, I have the x plus 2, I have the x plus 3. What I'm missing is that second x plus 2. So x plus 2 over x plus 2. For my second fraction, I have the x plus 2 and the x plus 2. What I'm missing over here is the x plus 3. All right. Now, first fraction, we're going to multiply x times the x plus 2. So when we do that, we get x squared plus 2x over our LCD, which was x plus 2, x plus 3, x plus 2. Again, on the denominator, it doesn't matter what order you write those down in, just as long as they're all there. Okay, minus. Here, we'll multiply everything by 2. So that would be 2x plus 6 all over our LCD, which is x plus 2, x plus 3, x plus 2. All right, now we're ready for the part where most people make their mistakes. This is a subtraction, so we must change it to addition of the opposite. So subtraction becomes addition. Positive 2x becomes negative 2x. Positive 6 becomes negative 6. All right, now combine like terms. We have x squared. 2x minus 2x is 0, and then we have negative 6. And then our LCD is x plus 2, x plus 3, x plus 2. This will not break down any further, so final answer. All right, problem H. We have x minus 2 over x squared minus 2x plus 1. So I'm going to factor this first denominator to x minus 1, x minus 1. My second denominator, or my second fraction, we have x plus 4 over x squared plus x minus 2. I'm going to break that down to x, 2, and 1, making the 2 positive, the 1 negative. All right, so my LCD, I need an x minus 1, an x minus 1, and an x plus 2. So on my first fraction, I have the x minus 1, but I'm missing the x plus 2. On my second fraction, I have x plus 2, and I have one of the x minus 1, so I need another x minus 1. Okay. All right, now I'm going to need a little scratch paperwork down here, so I'm going to move this up just a little bit. So on my first fraction, if I want to multiply these two numerators together, x plus 2 times x minus 2, let me write it down over here, x plus 2, x minus 2. So this would be x squared minus 2x plus 2x minus 4. So that would give me x squared minus 4 over x plus 2, x minus 1, x minus 1. Minus. Now on the other side, we are multiplying x minus 1 times x plus 4. So that would be x squared plus 4x minus x minus 4. So that's going to give me, on the top, x squared plus 3x minus 4 all over x plus 2, x minus 1, x minus 1. All right, now we're ready for the trickiest part. Not the hardest part, the trickiest part. Because subtraction is addition of the opposite. So this subtraction would become plus. Positive x squared would become negative x squared. Positive 3x would become negative 3x. And negative 4 would become positive 4. Now we can combine like terms. So x squared minus x squared is 0. Then we have a negative 3x. Negative 4 plus 4 is also 0. So once we combine like terms here, all we're left on the top is negative 3x over, and then just write your LCD, x plus 2, x minus 1, x minus 1. And you can see here, nothing's going to factor any further. So this is in its simplest form. And that concludes today's lesson, Adding and Subtracting Rational Expressions, Part 2.